All right, in this video, I'm going to show you how to use a TI-84 to get probabilities from normal distributions without needing to use the standard normal table found in your AP Stats formula sheet. So first thing you want to do from the home page is navigate to the list of distributions in your calculator menu. So to do that, you click on Second, and then this VARs button to get to the distributions menu. Now these first three are the ones that have to do with the normal distributions. They say normal or norm to represent the normal distribution. Now this first one, normal PDF, we're actually not ever going to use that one. We are just going to use normal CDF. Okay, CDF stands for cumulative density function, in case you are curious. So if you want to get probabilities from a normal distribution, you go to this option and you are going to put in the lower and upper bounds of the region you are trying to find the area of. So let's take a look at an example so I can show you just real quick. Hold on, let's come back here. Let's say we are trying to find the height or the probability that a randomly selected adult male in the US is at least 72 inches tall. Okay, so that means in our normal distribution, we would have a lower bound of 72 and an upper bound technically of infinity, because normal distributions go all the way down to negative infinity and all the way up to positive infinity. Now obviously we can't actually type infinity, so instead we use 1 times 10 to the 99th power to represent a really big number. Okay, then we need to update our mean and standard deviation. The calculator defaults to a mean of 0 and a standard deviation of 1 for the standard normal distribution, which is great if you're working with z-scores. If not, you need to update this to the mean and standard deviation of the normal distribution you are working with. In our case, men in the US have an average height of 70 inches with a standard deviation of 3. Then you click paste and enter, and we find that about 25% of men are more than 72 inches tall. All right. Now, if you want to do the same thing, but for an area to the left, let's say we want to find the probability that they are less than 76 inches tall, we're going to follow this same pattern. Okay. Second VARs, select normal CDF, but now our lower bound is negative infinity. We can't really type negative infinity, so we use negative 1 times 10 to the 99th power. Upper limit here of 76, same mean and standard deviation in this example. Enter, and we find that 97.72% of men in the US are less than 76 inches tall. We can also use the calculator to get this third probability, the probability that a randomly selected man is between 65 and 69 inches tall, by doing the exact same process, this time with a lower bound of 65, an upper bound of 69, and we get our probability of 32.2%. Okay. Now, it is important to remember that on the AP test, if you choose to use your calculator to get a normal or a probability from a normal distribution, that is perfectly fine, but they need you to write out what you did in a very specific way. I have an example of that down here. Okay, you are going to specify the calculator function you used, in this case normal CDF. You need to specify all of your inputs, the lower bound, the upper bound, the mean, and the standard deviation. If you do not enter it in that exact way, then, in this exact way of labeling the various inputs, AP will not count that as a correct response. Okay, so you need to, if you choose to use the calculator, you need to label it in this manner. All right, we have one other calculator function to show you, and that is the inverse normal function. Okay, this is going to do kind of the exact opposite of normal CDF. With normal CDF, you input values from the distribution, and it gives you the area in between those two values. Inverse normal, instead, you are going to enter in the area, the mean and the standard deviation, and which direction you're trying to find the area for, and it will give you the value. So for example, if we wanted to find the value in our normal distribution that has, let's say, 30% of men shorter than it, we would enter our area of 0.3, mean of 70, standard deviation of 3. Left, right? Tail left means area to the left. So the value that has an area of 0.3 to its left is 68.4. So 30% of men are 68.4 inches or less. Okay. If you wanted to find the value that 90% of men are taller than, you could use inverse norm, 0.9, and we would change the tail to right. 90%, the value that has 90% to its right is the value that 90% of men are taller than. Paste that, and we get 66.16 inches. Okay, this is really good for finding percentiles because if you remember, the definition of percentile is the value that has that percentage of the distribution less than or equal to it. So if we wanted to find the 75th percentile for adult male height in the United States, we could type in 0.75 as the area to the left. This gives us our 75th percentile, 72 inches.